So data types, you probably, if you're taken my statistics class, have heard me use these terms before. So when I would say numeric or continuous, it's officially called numeric in R, is a string of numeric values or numbers. So in this case, I gave an example of 1.2, 2.6, 3.4, and so on and so forth. So these would be numbers that have decimal points. Those would be considered numeric values. So the second type that is really common are character values. So character values are always surrounded by quotes, and then they have letters in them. So as you see here, the state names here would be a character. Those would be character values. You're seeing here, and I will cover more about this later. So the C in front is to make a vector in R. We'll talk more about that later. But it's just to create an object, and we will cover that in a bit. Factor variables, I'm going to come back to those because they're a lot more complex. One more thing about character variables. If you have, say, a string with both numbers and letters in the string, it will automatically be made a character variable. So if there is one letter in a string of numbers, it will automatically be made to this. So that's something to keep in mind, because when you're working with data, if an individual accidentally put an A in the middle of a numeric column, it will show up as numeric always. So is there a question? Okay, if not, mute your microphones, please. So the next value I'm going to talk about, similar to numeric, is integer. So these will be numbers without decimal points. So if you just have numbers without those decimals, automatically load as an integer. So that is another type. Finally, there is logical. Logical is either true or false. So one thing that I believe I mentioned last time that you need to keep in mind here, R is case sensitive. If any of you are SAS users out there, this is going to be new for you. So if I had a capital T and lowercase r u e, this would not work. When you work with logical, it's either true or false, and they're on all caps every time. So one thing, instead of writing out all of these can be abbreviated as capital T and capital F. If you ever see me do that, they are equivalent in R. So these are true or false. One thing that I want to mention, and I will get more into this next, but these are coded true and false. You'll see the label of true and the label of false, but they're actually in the back end, or like R stores them as 1 and 0. So true on the back end is a 1 and false is a 0. This will come in handy when we're talking about indexing in the next intro R programming class. So keep that in mind. But when you use them, you're going to see this true and this false. That's how you're going to see them when you work with them. So like I said, we'll get back to factor variables in a little bit. Are there any questions about those 4 data types before I move on? Okay, great. So checking and changing a data type. So in R, the class function will allow you can put a data frame. This is a data frame, and we'll get more into data frames in just a moment. So we're looking at the city column within the location.df data frame. I wanted to show this because if you don't know what type of variable that you're looking at, if you use this class function and put the column in here, it'll tell you it's a factor. Say you don't want a factor variable. Say you want it to be a character variable, so just text or numbers. You can use as character and then assign that again to that original value. So we're using as character, and we're putting that column that we want to change right here. And then we're assigning it to that same column. So that is going to change the type. So you're going to see that there's a pattern here. If you want to change it to as numeric, it'll be as.numeric. If you want to change it to a factor, it's as.factor. As.character changes it to a character. And this even works for the thing that we're about to cover. You can actually change the data structures as well. So if you want to change something to a data frame, as.data frame will work as well. The same thing for lists. One thing that I struggled with making this class is I had to cover things or mention things that I haven't covered yet. So if you're wanting to know more about a data frame, we're about to get to that. But the main idea is to change a data type or structure, use as, dot, and whatever you want to change it to. Another thing that I did not include in this slide, class is usually easier to use because it will show if it's a factor or a character or a numeric. You can also use is.numeric and it will return true or false based on if it's a numeric variable or not. So that's something else to know. But this tends to work better because it will actually tell you the values. So one use case for using is.numeric, there is a function that you can change all of your numeric variables in your entire data set to character variables, for instance. So if is.numeric equals true, then it will change it to a character. And we'll go over that in later classes. But that would be a use case for the is.numeric versus the class. Are there any questions so far? Okay, so now we're going to get into the data structures, what we just talked about in passing. So first thing I want to go over is the most simple idea here. So in R, you can store into some type of name. So in this case, state is I think of it as a variable. So state, and then we can use this later on. So I'm assigning the value Texas, which you'll see the quotes around it. That means it's a variable. I'm assigning Texas to the object or variable state. So what this means in practice is that Texas and state in R will be indistinguishable from one another or exact same. So if you type state, it will mean the same exact thing as if you typed Texas in all of your code. One thing that I try to students that I've run into many times. So say you are running an analysis where you want to run something for all 50 states, but you try Texas to start. You would always want to put that state name to a state object. The reason for that is in R, you always want to avoid hard coding if at all possible. Hard coding is, so every time you refer to Texas, if you wrote out Texas, that would be bad practice. The reason is if you, for some reason, wanted to change Texas to Missouri or New York or anything, and you typed out Texas 20 times in your code, then you would have to go through and change 20 values in your code. Whereas if you assign Texas to state at the start, all you would have to do is change one piece of code, change this Texas to Missouri or New York or Arizona. And then every time if you refer to it as state in the rest of your code, then you only have to change one line versus 20. So that's something when I go through all these things, I try to put in tips and tricks as when you go on, you'll learn more about them, but things that I've run into and done wrong in my own career. So that is an object. So this is basically what we are assigning the variable or the object that we're assigning Texas to. And if you'll remember, I went over last week, this is the assignment operator. So that means that we are assigning Texas to state. So that's this caret and then a hyphen. So that is easy to do in The next thing that I wanted to talk about, and I'll go into more detail in a minute, is a vector. So everything in R is made up of vectors, almost every. So what this is, you'll notice that in front of every vector, there's always a C and parentheses, and then it'll have what is inside the vector inside that. So one thing that this will be familiar from just a minute ago. So in vectors, all vectors have to have the same type of values in them. And then they will consist of one dimension, meaning that this has a length of 5 and it doesn't have rows and it doesn't have columns. So we're only seeing one dimension here. So when you look at length, it'll say it has a length of 5. If you ask the number of rows for this, it would throw an error. So this is a vector. And say, for instance, you had an A instead of this 2. As I said earlier, if you have one character variable inside of a numeric, or the rest of it is numeric, it will automatically change it to a character variable. So you have to have one single type in vectors, and if you don't, R will force it to have the same type. So in that case, it would change it to character. So, and we're going to see the same syntax that we saw up here. So we have this assignment operator. This is our vector, and we are assigning it to the name numbers. So that is what we're seeing here. We're going to go over this in a little more detail in a second. And all of these, this is kind of a beginning summary, and then we're going to deep dive into each of these individual data structures. So the next thing is a list. So a list is similar to a vector. It will look very similar when you type it out. The big difference when you're actually using it is instead of the C, there is a list in front of it. The other large difference is that you can have more than one type of value in your list. So you'll see I have a numeric value here, I have a character value, another numeric, and then I have a logical. So that's totally fine when you're using a list. So that is what the major difference is and why you would use a list instead of a vector in some cases. But this one is also going to be of one dimension. So that means that it's not going to have rows or columns. It's just going to have a length in this case as well. So I'm going to get into more detail, but are there any questions about the things that I just went over at a high level? Okay, great. So now these are the things that you'll be more familiar with. So first, a matrix. A matrix looks similar to, so picture something that you're using in Excel. So a matrix is going to have rows and it's going to have columns. The only difference between something that you use in Excel and a matrix is that the entire matrix has to be of the same type. So you can't have numbers and characters in that matrix at the same time. Again, you're going to see the same exact rule that if you have all numbers and one character, it's going to force the entire matrix to be character variables or character values. So, but a matrix will have a number of rows and a number of columns. It will look similar to what you've seen in Excel, except they have to be all of the same type. We're going to get more into that in a little bit. And then the data frame is exactly what you will be used to seeing in Excel. So if you have a sheet or something open in Excel, chances are it would be considered a data frame. That's usually what we feed into our code is a data frame. I'm actually going to go in. So today's code is here. I'm just going to real quickly go down here and read in the data that we're going to be using later. So we're seeing that this is a data frame. That's what this would be considered. So it has a number of 12 rows. It has 3 columns, and you'll see that states are one data type. temperature data type, and temperature group is also one data type. So we are seeing there that these individuals are all of the same type. There's no characters in the temperature column, and there's no numbers in the state column. So that's the major rule for data frames, that each column has to have a specific data. So you can't mix within each column. But column 1 could be numeric and column 2 could be character, and that's totally fine. So this is what we're used to working with in Excel. And if we read in a .csv file, which is what we covered the last time when we're looking here, if we read in that .csv file, it will then it will be more than likely a data frame.